This week we're going to cover geology and inorganic chemistry. Actually, the inorganic chemistry is going to be rather superficial, but it will allow you to draw upon some of your knowledge that you have from that earlier activity. So anyway, the first chapter is chapter 17, Rocks and Minerals. And essentially this is the inorganic chemistry portion. Now the core idea here is that Earth is a dynamic body that cycles rocks and minerals through ongoing changes. And we are in Ozarks are very lucky. We have a preponderance of rocks here. The solid Earth materials has a non-uniform distribution of matter. And we have a lot of different types of, we have a molten core, but then we have a fairly thin surface crust. The molten core is mostly iron and nickel, and it contains most heavy elements. This is the whole Earth right here. And this shows that this is the Earth. They should have flipped these around the other position, because this right here is the Earth's crust. And you see that the most common element in the Earth's crust is oxygen, followed by silicon. Now, this is on the basis of total mass. It's not in terms of so that this aluminum weighs a lot more than oxygen, but there is so much more oxygen and silicon. And this right here is sand, right? And a lot of quartz and a lot of those things make up this material right here. And we're not talking about the atmosphere. The atmosphere we'll talk about next week. And you can see that aluminum is the third, iron next, then calcium, then sodium, potassium, magnesium, and all the other ones way down here. Okay. Now at the core of the Earth, if you include that as well, then iron makes up the majority, well, not the majority, 1/3 of it. Oxygen is reduced from 46 down to 29. Silicon is from 27 down to 15. And then you get magnesium, and aluminum is way down here. Okay? So, but in the upper areas, this is the composition of what we call the crust of the Earth. Okay? Now, we talked about this when we talked about the different ions. We have a chlorine and a sodium, and these exist in an ionic form, and they're a repeating structure, and it's a very nice type of structure. This particular is salt, or if you wanted to call it metal, not metal, it's ore, it would be called halite. When the people go down to the salt mines and dig out the salt, they're digging out halite. Okay? It's a naturally occurring inorganic solid element or compound within a crystalline structure. Cannot be synthetic. It's not directly produced by a living organism, and it has a very repeating unit. Okay? So this is what the bulk of our minerals make up. So this is the definition of a mineral. It's a naturally occurring inorganic solid element or compound with a crystalline structure. That is the definition of a mineral. And the example that they have here is one of the nicest and easiest ones because of the fairly similar size between sodium and chlorine here. It can be made up of one or more kinds of elements. That's right. If you have just diamond or a lump of coal, you only have carbon. Quartz has both silicon and oxygen, right? And so the little grains of sand on the beach are like quartz. Minerals can be arranged in different shapes based upon the arrangement of the elements in their composition. Silicates. These are some of the most common. Silicates include silicon and oxygen as the constituents, right? They've got silicon at the middle, and then they have oxygen at the 4 tetrahedral locations. So, and these have 4 different types of structures. This is a quite common one. This is isolated tetrahedrons. You can have chain silicates, right, where they have a whole series of them. You can have sheets of them, and then you can have framework silicates. Okay? And here's some examples that you can see where you have silicates of different types. This is one type of rock here, and this is more of a quartz type of rock here. Okay? I do believe this right here this is actually coal here. This is coal. And it's not, and this is the silicate over here. I don't know why they included this in here as well. Non-silicates. Okay. Yeah, that's everything else, right? They don't have silicon and oxygen, tetrahedrons, and they make up 8% of the Earth's crust. There are 8 groups of non-silicates. You have your carbonates, and we've worked with those when we had our lab of when we generated our carbon dioxide. And those are the most abundant following the silicates. You have your sulfates. They have sulfur in them. Carbonates consist of carbon and oxygen. Sulfates consist of sulfur and some other metal. Oxides, they consider any of the other metals and oxides, ferric oxide, for example. The sulfides, the sulfates have sulfur and oxygen and some other metal. The sulfides don't have oxygen in them. The halides have one of the halogen members plus one of the metals. Phosphates are phosphorus and oxygen plus some metal. Hydroxides you have your OH as an ion in these, not as an alcohol bond like we had last week. And then you have your native elements. There's a few of them, like copper and gold and silver, that exist all by themselves. So, in terms of a scheme of these, of separating them out, you've got your silicates first, right? And here you've got those where you've got some other thing in them, such as that will cause it to have magnetic properties. And these are called biotite, hornblende, augite, and ovine, right? These have iron in them, in addition to the silicates. So these are iron silicates. Non-ferromagnesian, okay? And this is quartz, muscovite, which is white mica, feldspar, which is aluminum silicates. And then you have the plagioclase, which is the sodium feldspar. So it's sodium aluminum silicates and calcium aluminum silicates. And then you have orthoclase, which is potassium aluminum silicates. Okay? And then you have the clays, which is chlorite, lignite, and kaolinite. Okay, those are the clay ones. These are the non-iron containing ones, and these are the iron containing ones. Then you have all the rest, the non-silicates. Your carbonates, this is your calcite and dolomite. Your sulfates are gypsum and anhydrite. Your oxides are hematite, which is iron oxide. Magnetite, which is another form of iron oxide. Ilmenite and aluminum oxides. Okay. Then you have your sulfides. Pyrite, that is essentially iron and sulfur. Sphalerite, galena, and chalopyrite. Then you have your phosphates. Apatite is phosphates. Your appetite for your stomach is quite a bit different spelling than this one, okay? But it's pronounced the same. And then you have your halides. Halite, which we talked about before, is sodium chlorite. And this is your fluorine-based one, fluorite. And then these are your native elements: gold, silver, copper, diamonds, and sulfur. You should also have coal on here as well. Okay? I know, it's not quite as nice as sulfur, but it still exists there. Physical properties of minerals. These are what you would look, how you distinguish them. Color, it's not very useful because you can have a whole lot of different things. People oftentimes mistake iron sulfide, which is fool's gold, for gold, and it has. You shouldn't make that mistake too many times, and it can be influenced by trace impurities. Okay, streak is the color of a material when finely powdered. Okay, and it's more consistent than color. So streak is a type of color, but it is finely powdered material gives you this one. This right here is just the bulk material, what it looks like. Hardness, this is resistance to scratching, and this is on the Mohs scale. And softest material is talc, and the hardest is a diamond, and this gives you the scale in which the different ones are located. And so gypsum, and the gypsum board, you know how easy that is to break that up. I mean, that's just your wall board, and it needs the paper on it in order to hold it together. Then calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. A lot of your grinding equipment uses corundum rather than diamond. Only the purists use diamond for their grinding operations. Okay, other ones. Here you have gypsum, and the hardness can be scratched with a fingernail here. Okay. It looks similar to this, but believe me, if you scratch this versus scratching this, you'll notice that it's quite a bit different. This is a hardness of 2. This is a hardness of 7. It takes a metal file to scrape this because it's so hard. Crystal form. This is related to the internal geometry, arrangement of the atoms. 6 basic groups, already mentioned for that. Cleavage. This is, does it break on a smooth plane? And that's one of the problems that causes the mudslides out in California, is because they have slate material there, and that will break off into a smooth plane. And so once you have rains come down there, those smooth plains are slick, and a house can go right down the mountainside. Fracture, this is a tendency to break along a smooth plane. Fracture is if it breaks regularly. This is when you take a rock and you have to break it up, and it forms all sorts of little pieces. Luster is the surface sheen, and this type include metallic, pearly, and vitreous. Metallic means a very shiny surface. Pearly is a lucent, opalescent type of material, and vitreous is just sort of a scummy type of thing. Density is mass to volume ratio. Another way of looking at specific gravity was the ratio of mineral density to that of water. 2 factors determine the density is the kind of atoms making up the material and the packing of the atoms in that crystal lattice. So the mineral forming process, okay, this is there are some things which actually do occur today, and we do observe those. What I'm not going to do is I'm not going to go into the evolution of the Earth according to some theories. What we have to do is we have to base things upon what we can actually measure now and what we actually see now. The formation of 2 liquid environments is most common. You have a water solution, and crystals form from highly concentrated ions. That's one for minerals can be formed from water solutions. And you have that where the salt water dries up. You get a whole lot of different crystals formed along a seashore. Molten rock from minerals can crystallize. That happen below the Earth's surface, and the lava is the magma forced out of the Earth's surface, and this all occurs during volcanic activities, and we've seen a lot of examples of that. Important factors for these different ones are temperature, pressure, how long at time, and the availability and concentration of the different ions in solution. Now, a glass is not really a mineral. This is a rapid cooled solid lacking a crystalline structure. So this does not have a crystalline structure. It is a rapidly cooled